Hello and welcome to today's daily Leetcode challenge. We'll be solving question 141, going through my thought process as I solve it. Finally, stick around for the end of the video where I compare my solution to the solution of others. And with that, let's begin the question. Question 141, linked list cycle. I'm going to say that I have already done this many times. Actually, this was probably one of the first questions that I've ever solved. It was given to me because of the very non-computer science approach and just basically being a logic problem, and being very easily explained on different analogies, like with like race cars or like horseback riding scenarios. Very fun question. So, all right, given a head, the head of a linked list determines if the linked list has a cycle in it. So only given the head of a linked list, which is the first node, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node. That tail's next pointer is connected to, so that pause is not passed as a parameter. Return true if the cycle if there's a cycle in the linked list. Otherwise, return false. So let me, I guess, start with the visual here. A cycle in a linked list essentially means that the linked list is endless, meaning that if you continue to iterate and continue to go next, node next, you would never have you would never reach a none. Now, why is that? Well, that is because next of the final node, which final node is an objective word, you would actually go into one of the previous nodes, making you endlessly go into this cycle. And so how do we find that, right? How do we figure out if there is this cycle in the linked list? You can't run an algorithm infinitely and then after an infinite number of iterations say that, hey, it's probably infinite, right? You really have to concretely find that that there has been a cycle somewhere before reaching the end, which sounds impossible, right? There is no end. So how do you actually go about this? Well, let me start with that. I didn't reach this intuitively. I think this took me a pretty long time to figure out, but the idea here is, imagine that two race cars start at at the same position in a circular arena. If they go at the same speed around the arena always, they're never going to cross each other. However, if one goes a little bit slightly faster than the first car, if one of the cars is slightly faster than the first car, they're inevitably going to cross paths again if there's a circular, if the arena is circular, right? If not, then obviously they're going to reach the end. But if they're not going at the same speed, then they're going to cross paths again. And so that's what you have to be doing here. Essentially, we're going to emulate the two cars with just two pointers. One's going to be going at one speed, the other one's going to be going at half the speed, and that's it. And if they happen to cross paths, that means that they simply have that they've been riding around in a loop. With that, let's begin the implementation. Examples are actually pretty simple, just visually showing you what a loop in a linked list looks like. There's 4 nodes, but actually infinite number of head.nexts. Same goes here, and with the exception of a 1. And so let's create our 2 pointers. I'm just going to call them P1 and P2. I'm going to say that the first one is going to be the one that's going slower, and that is going to be equal to head. The other one is going to be the one that's going faster, and it's actually going to be equal to head next if head, else none. Actually, let me check this if we're even allowed to have 0 indices, and we are allowed to have 0 indices, so I have to do this check here. Otherwise, if we're guaranteed to at least have 1 node, I wouldn't need this check. And last, while P1 does not equal P2, so while those two are not pointing at each other, I'm going to yeah, if they're not equal to each other, we say P1 is equal to P1 next, and P2, wait, sorry, what am I, no, sorry. P1, so while P1 and P2, sorry, quick restart of thought. I have my 2 pointers. I'm claiming that if they are not equal yet, then continue, no. Because I need to say that if they are the same. Oh, okay. While P1 does not equal P2, that's all right. I'm going to be saying P1 is equal to P1.next, P2 is equal to P2 next, if P2 next, else none. And here I'm going to say if P1 is equal to P2, return true, return false. That's it. So what am I doing here? I'm iterating to the next step. However, I'm saying that if once I've iterated to the next step, the pointers are actually the same, then return true. Otherwise, exit this loop and return false. And that should be correct. None type is not. So I thought that I got rid of that. Okay, then let's just say P1 and P2. So if they both exist. Because if they don't both exist, then I'm definitely just going to be saying that there's no loop. So, okay, so here I've updated the condition to be that P1 and P2 actually are nodes. So that's a bit cleaner, and I'm actually going to put this here now just to make it more understandable. I'm doing the check that P1 and P2 are the same before I skip to the next iteration. That's just cleaner. And if one of these pointers has reached a none, that means that we're actually done with the iteration and we must return false. I'm going to submit this and let's see Yep, we're all good here, and I did this years and years ago. Oh, 2 years ago. And yeah, top of the runtime count. But yeah, let's see what other solutions there are. It seems like, yeah, has cycle, visited. They're doing something else. They're doing something slightly different. You could use the input the input nodes as variables themselves, but that's just not clean. And I think that the approach, so yeah, an approach like this is way better. They have a fast and a slow, and while fast at next, okay, well, I did fast and slow. Essentially just go through and check if fast is ever equal to slow. One thing I'm confused about here is, wouldn't this create, like, I'm doing a check to see if head ever exists, because you can't call next on something that doesn't exist. But it seems like the description must be wrong, right? Because here it clearly says, oh no, he's doing a check here. So never mind. This is the exact same solution that I did, and it's a bit faster. So yeah, I would say this is way better than using the input linked list as something that you're like modifying the input. However, yeah, that's definitely a solution. And then there was another solution that utilized the write out file, which is just cheating, in my opinion. Anyway, well, thanks for watching. Have a good day. Please like and subscribe. Bye.